Good day. This is Russell Hawley coming to you from the Tate Geological Museum here at Casper College. And today I'm going to talk to you about one of my favorite minerals, and that is calcite. And calcite is one of the carbonate minerals. That is to say, it's made out of carbon atoms combined with certain other atoms. In the case of calcite, those are calcium and oxygen. So you have one calcium atom combined with one carbon atom, and then each of those pairs combined with 3 oxygen atoms, and that gives you a molecule of calcite. So CaCO3, that's the chemical formula for calcite. So that identifies it as a carbonate mineral, and calcite has the distinction of being the most abundant carbonate mineral in the face of, in the crust of the Earth. And it's found in all sorts of places. Limestone is made out of microscopic shells of sea creatures that are made of calcite. A lot of larger sea creatures, from trilobites to certain mollusks, have shells made out of calcite as well. And the things that are derived from limestone, like the stalactites and the stalagmites that you can see in a cave, those are all ultimately made out of calcite as well. So it's a very versatile and abundant mineral. And it has a number of features that enable us to identify it. Now, if you've got a nice clear piece of calcite, this is a piece of Icelandic spar, which is just a clear form of calcite. And if you get a piece of paper with some words on it and put it behind that piece of Icelandic spar there, it splits the image into a double image. So you look through this, and now there's 2 different images of the words. You got double vision, like somebody just kicked you in the head. And that's because as light enters the calcite crystal, it splits it in 2 different ways. No other mineral does that. It is a property unique to calcite. And if you've got a clear enough piece, that makes it very easy to identify. That also makes calcite useful for making things like rangefinders and polarizing microscopes. Now, another characteristic of calcite, one that we've alluded to before, is the fact that it has 3 planes of cleavage that are not at right angles to each other. So you've got different planes of cleavage meeting at these angles, and if you break off a piece of calcite, then it too will have those 3 same cleavage planes at those same angles. Calcite can make a variety of different crystal forms. This block is a model of one very common crystal form found in calcite, and it can also make shapes like this. This is a piece of what's called dogtooth spar. Once again, it's calcite, but now in a shape that, with a bit of imagination, resembles the tooth of a dog. But by far and away, the most surefire way of identifying calcite is the acid test. Calcite effervesces. When it's in the presence of acid, it produces bubbles. And you can see that by hitting your calcite specimen with hydrochloric acid diluted to 10%, or if you don't have hydrochloric acid, then vinegar can work. Now, I should warn you that vinegar won't produce as much effervescence, and if the piece of calcite is already a little bit weathered, or if it's very, very solidly cemented, it might not effervesce at all. So hydrochloric acid really is the way to go. If your specimen is not effervescing, what you can do is scratch at the surface a bit to create a powder. And that powder will have more surface area, and that'll interact with the acid more readily. So here's our piece of calcite, and here comes the acid, and this should effervesce. All right. Ready to hit that. Ooh, fizz, fizz, bubble, bubble. So, oh, and little puffs of gas coming off there as well. That's kind of neat. So that is the surefire way of identifying calcite. Subject it to the acid test.